When we look at the electrification systems themselves, what are, and I know we kind of touched on this a little bit already, but what are some of the safety factors that should be considered during the development or integration? And Harshal, maybe I'll start with you this time.
So while developing the components, you want to make sure, so wherever there's electrical connections, you want to make sure that they have different locking mechanisms, because we have seen firsthand where customers have tried to plug the DC positive into the DC negative and vice versa, and then they have issues occur. So you want to have different locking mechanisms. You want to have HVILs set up properly, as Mike mentioned in the previous questions, because that's one sure way. And you also want to have a cutoff line for the HVIL. So if at any instance you cut that, it's a sure way to know that the high voltage is cut off at that instance and you don't have any high voltage.
I see the safety at a little bit high level, and for me, it's two components. The first one would be the what we can call intrinsic safety. So this have to do, as Herschel mentioned, with about the electrical voltage, the current, etc., the isolation, and so this is preventing electrical shock from the electricity behind. So that's one aspect. But there is another aspect which is have to do with the battery. Like if you are using electrical system, most likely that or often you will be using batteries on that system. So the batteries themselves introduce another set of functions of challenges, safety challenges. So it has to do with the again electrical things during the charging. You get connected. Like the vehicle is independent, but you get connected to the electrical grid. So there is there is safety hazard. The batteries themselves, they work on chemical reactions, and there is like very nasty chemicals there, acids, lithium, nickel, for example, nickel, cadmium in different things that can spill or can damage or can explode. So that's the problem there. And the batteries themselves, they pose, especially certain chemistries of the lithium ion batteries, they can pose a risk of thermal runaway in itself. So that's in addition to all the risks that are worked there. Then there is the other aspect, which is actually have to do with more of functional safety. So for example, now this vehicle is now driven by electrical systems, by processors. So we have to be sure about like the control system, for example, braking, steering, automation, or how the power got in and out, and disconnected. And we look at the auxiliary systems because there is safety, there is communication, there is this that are powered by an auxiliary system. The last aspect, which is actually now we hear a lot about the buzz in the industry, and it's introduced to a certain extent by electrical system, is cybersecurity of this system. So these are the different aspects that need to be considered when looking at the whole system.
I think actually one of the big factors is that for us in off-highway electrification, I think it's a little different than automotive, and we have to consider the fact that virtually every component, every piece, every work function on the machines can kill you. So on automotive, we look at functional safety, we steering, braking, and say, okay, those are the items that have to meet certain functional safety requirements. I would say to consider the fact that all functions, almost every single function on an off-highway vehicle should fall under the functional safety category. And I think as anybody's doing development or integration, I really want to see the industry just move towards that of there's no part of a heavy vehicle that can't kill you. So let's just say the whole vehicle, everything needs to be functionally safe. And I think that's probably one of the biggest factors to consider.
I mean, one thing that not everybody puts a lot of thought into is like fringe environmental conditions. Operators find a way to put these systems into, call them unique scenarios that may not have been considered when you were developing a product. You need to take into consideration some of these fringe environmental conditions. Is the operator going to drive it through a puddle that's up to the waist deep and submerge some of these products? Is everything placed in a location that can withstand that. You have the proper sealing on your products to withstand that.
Mhm.
Operators have a way of finding the chinks in the armor of the systems you develop.